Okay, hi everyone. We are going to look right now at solving one-step equations and solving them showing your work algebraically, meaning that you are going to systematically, mathematically show how you're getting a variable by itself to solve for what that variable must stand for. So we'll do just a few examples. Let's do example number one, and let's look at an equation that looks something like this. How about x plus 12 equals 30? To solve this, it means we're trying to figure out what that x must stand for, what the variable must stand for. Now, in your head, I hope you can do this. I hope you can figure out what plus 12 equals 30. What we're going to look at is the method that will let you solve this and the next level up and the next level up and the more complicated problems that we will continue to see through pre-algebra and algebra. And you'll have the method so that it won't feel like it's a harder problem once we get to the more difficult ones. So the idea is that this is an equation. This is balanced right here. Everything over on this side has to equal everything over here on this side. So what that also tells us is that we can do whatever we want to the equation as long as we do it to both sides. If I wanted to, I could add a million to this side over here, but then it wouldn't be equal anymore unless I added a million to this side over here. So I can do whatever I want as long as I do it to both sides. The key is to pick what's going to be useful to us to do to both sides of the equation. So if my goal is to figure out what x is at the end, I want x by itself. I want it to say at the end down here, x equals something, and I want to have a solution. So in order for me to do that, what has to go? What needs to get out of here? That plus 12 needs to go because we want the x by itself. So the question is, how do I get rid of a plus 12? How do I make it go away? Well, if I really want it to go away, I'm going to do the opposite. Instead of plus 12, I'm going to subtract 12. Isn't plus 12 minus 12 just 0? So I can do that, and this goes away. Bye-bye. See you later. But I'm only allowed to do that over here if, on the other side of this equal sign, I also subtract 12. That's the only thing that's going to keep this an equation and keep both sides equal. So if I do it on both sides, I'm going to draw lines, and I'm going to bring down what's left. What's left over here? This went bye-bye. See ya. So we're going to bring down what's left, which is x. I'm still going to bring down this equal sign. That stays this whole time. And I'm actually going to do this math. What is 30 minus 12? 30 minus 12 gives us 18. So look, in doing that to both sides, I'm left with a solution. I'm left with x equals 18. That's my solution. I'm done. I've proved it mathematically by showing what I did on both sides of the equation. And if I want, I can check it by just plugging it back in. If x equals 18, well then, 18 plus 12 should be 30, which it is. So we're using the strategy of showing work on both sides of an equation to be able to solve different equations. My marker is not working very well here. Let's go back to a different color. All right, for example number 2, why don't we try something like this? X minus 2 equals negative 10. So for this one, I'm using that same strategy. I'm just going to draw kind of a dotted line through my equal sign to remind me that whatever I do to one side, I need to do to the other. How am I going to get this x by itself? What needs to go? In this case, that minus 2. The minus 2 needs to get out of there. So how do I get rid of minus 2? Well, minus 2, if I did the opposite and I added 2, minus 2 plus 2 is just 0. That's going to cancel out. Bye-bye. See ya. But whatever I do on one side, I have to do on the other side. So if I'm adding 2 here, I also have to add 2 here. And now I'm going to draw a line and just see what I have left after that process. All I have over here left is an x. That minus 2 went bye-bye. Bring down my equal sign. And now I have negative 10 plus 2, so I have to know how to add my integers here. Negative 10 plus 2 still is negative, but it's a little bit closer to 0, negative 8. So now all I'm left with is x equals negative 8, and that right there is my solution. If I plug it back in, does negative 8 minus 2 take me down to negative 10? Absolutely. So again, the same method where you're showing what you're doing on both sides. Let me show you what it might look like with a multiplication or addition equation. Let's do example number 3. This one was I think I said addition, multiplication or division equation. This one was an addition. This one was a subtraction. Let's do a multiplication. How about negative 2x equals 24? That means negative 2 times x. If you don't remember, when there's nothing in between a letter and a number, it means to multiply. So what needs to go away to have the x by itself here? Well, that negative 2 times needs to go. How do we get rid of times? Well, we do the opposite. What's the opposite of multiplying? The opposite of multiplying is dividing. So if I'm multiplying by negative 2, the way to get rid of that would be to divide by negative 2. Because negative 2 divided by negative 2, anything divided by itself is just 1. So when that crosses out, that just becomes a 1. And what's 1 times x? Just x. All that would be remaining over there is just an x. So if I divide by exactly what I want to get rid of, what I was multiplying by, it'll become a 1 and it'll disappear. Whatever I do on one side, I have to do to the other. So if I was dividing by negative 2 on this side of the equal sign, then I need to divide by negative 2 on this side of the equal sign. And what's 24 divided by negative 2? Positive divided by a negative is a negative 12. And I bring down my equal sign, and there's my solution. X has to be negative 12. And let's do one more with a division problem, division equation. Example 4. Let's try something like x divided by 6. Ooh, that was a curly 6 down there. X divided by 6 equals negative 4. Okay, so looking at this one, what needs to go away to get the x all by itself over there on that side of the equal sign? Yeah, this divided by 6 needs to go. So this time, to get rid of dividing by 6, what's the opposite of dividing? Multiplying. So I'm going to multiply this whole side by 6. And in doing that, dividing by 6 times 6 cancel each other out. Whatever I do on one side, I'm going to do on the other side and multiply by 6. Those went away, so all I have left is x, and negative 4 times a positive 6 is going to give me a negative 24. So there is our solution. So these basic steps are going to be the building blocks for you to be able to solve all types of equations throughout this year and in the years to come. So make sure you're showing your work for what you're doing on both sides of the equation.